In this meeting, we will talk about our LAB11, which includes JK, SR, and D, and these three flip-flops. And then we have a master slave additional circuit. So first we will move on to our JK flip-flop, and using this truth table, we will get our results. So this is our property circuit I have designed. So first we have enable on and 1100, and we have no change in our output. Then we will get our input 01, and we have 01. Now we will turn off this enable switch, and we will give it 10. So we have 10, and then we have 11. So get v q bar and q10, which is equal to 10. And this is our clock. These are our two NAND gates, and these are also to our two NAND gates. This is our jockey, and this is our enable switch. These are our outputs. I didn't mark there, and JK are our inputs. So we'll move on to our next circuit. After JK flip flop, we will move on to our DV flip flop, and this is our truth table. And this is a producer circuit I have designed. So we have used four NAND gates, and these are our two logic probes, and we have a logic input here, and which goes through this channel, and we have used not get here. So if we have 0 here, we'll get 1, and if we have 1 here, so we'll get 0 for this channel, and we will circuit when current will move through here, and we will get our outputs q and q prime. And this is our clock. Sometimes this clocks as we close the file and then open it, this clocks creates problem in our simulation. So we delete it and put it again here and connect with the circuits, and it works. So here we have our two inputs. First we will give D1. So our when there we have D1. So here we will have D prime is equal to 0. So we will get our result 1 0. So here you can see 1 0. Now we will input our 0. So this will be 1, and this channel, so z have 0 0 1. Here p 0 and q prime 1. So that's it. This is a D flip flop. Then now we will move on to our SR flip flop. Now in our SR flip flop, we have this circuit that I have designed. We have set and reset. So basically there we have two inputs, and this is our clock here. These are our four AND gates, then these are our logic probes. Q and Q prime are our outputs. So I will give four combination of inputs. So we'll simulate it circuit here, and here there we go. 0 0 0 1, and then we'll count 0 1, then we will 1 0, and then we have 1 1. So here due to clock it will blink. So this is our SR latch, and now we'll move on to our final circuit of today, which is master slave, which is similar to our D flip. Here we have our final circuit of today, and this is a master slave flip flop. And here we have one inputs, and this is the D, and this is the D prime. So it will be inverted 0 1 or 1 0. So we'll go through here, and here we have four NAND gates, 8 NAND gates, and two NOT gates, and these are our two logic probes, and this is our logic input, and this is our clock here. So it's basically an extension of D flip flop. So we will here this shows us the error, clock error, and so simulation failed due to this clock error. So we'll remove this clock, put a new clock here, and just join it to this circuit, and we'll simulate now. This is our simulation ready. So where we will put, we can input two values only, one, one. So this will be one, and this will be zero. Now the prime will be. So we have one and zero, and now we have zero, and here we have one. So that is zero one. So today all of our simulations are successful. So thank you for watching, and Allah Hafiz, and that's it for Lab 11. Thank you.